Good morning, all of you. So today we will be discussing a few aspects about laterite soils. So I'll share the PPT. So we'll discuss certain aspects about laterites and lateritic soils. And I am Dr. Jayamohan J, Professor and Head of Department of Civil Engineering, LBS Institute of Technology for Women, Thiruvananthapuram. And this will be an overview of my presentation. First, we'll be having an introduction to laterite soil, then a review of definitions of laterite, and the geotechnical implications of the genesis of laterite soil, and certain aspects about the laterites of the state of Kerala in India, and references. Now, laterite soils are the most common soils whose color is reddish, and these are tropically weathered photogenic surfaces. These are found in the regions of Australasia, Africa, South America, and India. It is basically referred to as soil and rock type, and it is rich in iron and aluminum, and is commonly found in hot and wet tropical areas. Nearly all laterites, most of the laterites, their coloration is of rusty red, and that is due to the due to the high iron oxide content. Now, these laterite soils, they are formed due to intensive and prolonged weathering of the parent material. This tropical weathering, this type of weathering is commonly known as laterization. It is a prolonged process of chemical weathering. So usually, every rock, due to chemical weathering, clay minerals are formed, but this is a prolonged process of chemical weathering. So after the formation of clay mineral, chemical weathering further continues, and which results in the formation of lateritic soil. So here, this lateritic soil varies widely in thickness, in its grade, chemical composition, in its mineralogy, etc. Now, the majority of lateritic deposits, they are found between the tropics of Cancer and Capricorn. Now, initially, this laterite soil, this term was given to this soil was by a traveler named Buchanan. Buchanan in the earliest 19th century, that is in 1807, he traveled through the present day Karnataka and North Kerala. Those days, these were different kingdoms. These were the kingdoms of Mysore, Kannada. Kannada means southern part of Karnataka and Kasaragod, those area, and Malabar. And so Buchanan traveled through Mysore, Kannada, and Malabar, and his travel details are recorded in the book authored by him titled "A Journey from Madras" to the countries of Mysore, Kannada, and Malabar. And he wrote this book in the year 1807. And the earliest references to laterite soil is found in this book, and especially in pages 440 and 441. Now we'll see the excerpts from his book. He refers that this soil is formed in the region of Malayala. I think probably he is referring to the state of Kerala, because in 1807, state of Kerala was not yet formed. And he describes as it is full of cavities, pores, and contains very large quantity of iron in the form of red and yellow ochres. Ochres means it's a sort of pigmentation type thing. Now, in this mass, when it is removed, that is when you cut it and remove from the soil in the form of a block, initially it is very soft, so that we can easily cut it with a knife. But on exposing it to air and water, it hardens. It hardens and becomes something like rock. So that is how he has explained about laterite. And he says that in the native dialect, it is called brickstone, or in the native language, it used to be called as Ittiga Kalle. Ishtiga means brick in the language of Malayalam. So those days they used to call as Ittiga Kal means brickstone. And its color, he says, it gives a resemblance to the skin of a person affected with cutaneous disorder. Cutaneous disorder is a skin disease. In skin, we will be getting some sort of red and white, some sort of red and white coloration. That's a type of skin disease. We call it as cutaneous disorders. So Buchanan says the surface of laterite resembles the skin of a person affected with this cutaneous disorder. So in native Tamil language, see, you can see in native Tamil language, it is known as chorikal or means some sort of itching stone because of that appearance. Anyway, Buchanan suggests that in English, the most proper English name would be laterite. So this term, this nomenclature of laterite was given to this type of material by Buchanan in 1807. And this is a monument in a place called Angadipuram in the Malabar region of Kerala. This is a monument of the visit by Buchanan, and it has been discussed in the literature of Buchanan and Hamilton in 1807. Now, coming to the distribution of laterite worldwide, laterite is this light green shade. It is found somewhere in South America and some portions in the central parts of Africa and in India along the western coast of India and in other countries as well. So these are the places where laterite is found in abundance. And in India, if you see, the distribution is mainly in West Coast and certain portions of East Coast and some pockets in Middle India and also in the northeastern part of India. So these are the places where laterites and lateritic soil is found in abundance in the nation of India. Now, we will have a brief review on various definitions of laterite. Laterite, you see, it has been defined based on its hardening property, based on its chemical aspect. There are chemical definitions. Later on came morphological definitions based on its mode of origin, etc. and all. So these are the three different types of definitions. Now, based on hardening property, the earliest definitions was given by Buchanan himself. He says he describes laterite as a ferruginous, having a lot of iron content, vesicular, unstratified, and porous material with red and yellow ochres. Ochres means it's a natural clay earth pigmentation, which is a mixture of ferric oxide and with varying amounts of clay and sand. That's referred to as ochres. And having a high iron content. It is found predominantly in the Malabar region of Kerala. And the freshly dug laterite, that is quite soft. You can cut it using a simple steel instrument. But with time, once you keep it exposed to weather, with time, it hardens. It hardens, so that is a weathering, and it is highly resistant. Further, it is highly resistant to the weathering effect of climate. So this is something reported in the earliest part of 19th century. And then towards the mid of 19th century, Blandford, and in the earliest part of 20th century, Harrison, they reported this, the hardening of lithomarge. Lithomarge, laterite is also referred to as lithomarge, and it is referred to as lithomarge and red sesquioxide poor materials. The sesquioxide means it is an element combined with oxygen. So the combination is that element and oxygen are mixed in the ratio of 2:3. That two parts of the parent element with 3 parts of oxygen. So 2 parts of parent element with 3 parts of oxygen. These are known as by this term sesquioxide, right? Now, similarly, In the last part of 19th century, these people, Mallet and Bauer, they also reported about laterite. Mallet reported the chemical concept of laterite as ferruginous and aluminous in nature. Similarly, Bauer, he reported about the relative insignificant content of silica and high contents of aluminum in a hydroxide form comparable to the composition of bauxite. So once upon a time, in the earlier parts of the 20th century, this laterite was also considered to be a potential ore for aluminum because of the high aluminum content, like bauxite. Then in the 20th century, Warth and Warth, they reported that some Indian laterites has got only small amounts of alumina rich in iron oxide, and whereas in some other places the lateritic were the composition of laterite was vice versa, that is large amounts of aluminum oxide and relatively poor quantities of iron. So these were the definitions based on hard. And now continue with the chemical definitions. In the 20th century, further Fermer, he defined various forms of laterite based on its ferrous, aluminum, titanium, and manganese contents. And Lacroix, again, he divided laterites into two laterites, silicate laterites, and lateritic clays. All these are by various researchers based on various parameters. They classify laterite into various different terminologies. Then again, towards 1930s, Martin and Doyne, they based on the silica alumina ratio, they classify laterites as true laterites, lateritic soils, and non-lateritic tropically weathered soil. So that was another different type of classification system. But further later, all these these definitions based on hardening property and this chemical definition later paved way to the morphological definitions part. Now, again in the 20th century, simultaneously morphological definitions also came up. First person was Walther. He proposed a morphological definition to laterite as a red-colored, brick-like alluvial and tropical red soil. That was one morphological definition which was given laterite. Later towards the mid of 20th century, Kellogg, he divided laterites into four principal forms of sesquioxide-rich materials, either which are hard in situ or which are capable of hardening later on exposure to air. Then towards the second half of 20th century, Alexander and Caddy, they defined laterite as a highly weathered material, rich in secondary oxides of iron, aluminum, or both. And it is nearly void of all bases and primary silicates, and also sometimes it may contain large quantities of quartz and kaolinite. Usually we observe large chunks of kaolinite within laterite. It is either hard or capable of hardening on exposure to atmosphere. Anyway, this short review of laterites, they reveal their complexity and they defy any satisfactory geological, chemical, or pedological definition. It's a bit complicated material by origin. Now we'll see what are its implications. Now, the property of laterite largely depends on its genesis, its mode of origin. We will see what are the geotechnical implications of the genesis of laterite soil. There are many implications. There are chemical implications, mineralogical implications, morphological implications. It's the genesis, the mode of formation influences the leaching and the concentration of sesquioxides and dehydration of hydrated sesquioxides and secondary minerals. So these are various implications. Now, you see, under temperate conditions, that is where the extremes, where there is no extremes of temperature or rainfall, the chemical weathering process will end with the formation of clay minerals. It doesn't go past beyond that. But in tropical climates like India, where temperature is high, rainfall is heavy. These clay minerals, the clay minerals formed due to chemical weathering, further decompose into various types of aluminous and iron oxide, depending on the weathering conditions. So this is what happens in, especially in tropical countries. Now, this is the reason why behavior of lateritic soils it is different from the conventional soils like sand and clay, which are these concepts are developed for soils in the temperate zones. So behavior of soil laterite is slightly different from that of sand and clay. It is due to the free iron oxide content, and there are three things. One is the free iron oxide content, then is the state of alumino-ferruginous complexes, the relative contents of aluminum and iron oxides, and then its unique structure, its unique granular structure. These are the three different aspects of laterite soil, which makes it slightly different, which makes it to behave differently from that of sand and clay. Now, the chemical implications are, it has got a high constant of either iron or aluminum or titanium oxides in relation to other constants. And it mainly, and basically due to this tropical weathering and the process of laterization, what happens is a chain of chemical and leaching processes occur. So due to this tropical weathering conditions, and this process of this laterization, a chain of chemical and leaching process which occur, which will cause two things. That is either partial or complete removal of silica and alkaline components and alkalis. So it will partially or completely remove all the silica and the alkaline soil and alkalis, and it may accumulate accumulation of aluminum, ferrous, titanium, and manganese oxides happens. So the silica and alkaline part gets removed, and accumulation of aluminum, ferrous, titanium, and manganese oxides happen. And this is the basic difference. And in 1936, Cooper, he constructed a diagram showing the chemical composition of lateritic soil at various stages of its formation. The initial stage he is terming as metabasalt, and as the stages change, then comes the stages of keratophyre or phyllite, then comes the stage of lithomarge, etc., etc. And these are the variations of various components at various stages of formation of laterite. Now, coming to the mineralogical implications, the primary materials due to chemical weathering are initially converted to clay minerals. Initially, due to clay minerals, due to chemical weathering, the parent rock is chemically weathered and clay minerals get formed. Then, due to leaching and all, some of the mobile constants are lost, and the residues of oxides and hydroxides crystallize out. Then here, the intensity of chemical weathering is controlled by two aspects. One is the amount, intensity, and distribution of rainfall. And second is the time duration of exposure of these minerals to weathering. So these two parameters control the intensity of chemical weathering. And the composition will indicate the age of that deposit. Now this figure shows the typical variations of the mineralogical composition in laterite profiles in relation to degree of weathering. Based on the degree of weathering, what is the variation of mineralogical composition? It was reported by Craig and Lognan in the second half of 20th century. And this is the distribution of laterite deposits in the state of Kerala. As you can see, it is distributed throughout the western coast of the state of Kerala. Now, coming to state of Kerala, this state is situated in the southwestern part of India. It is referred to as type locality of laterite. This laterite term was initially coined by Francis Buchanan, and you see the Midlands and the highlands of Kerala we call as Western Ghats, that is subdivided into three portions. One is the central Sahyadri, the Nilgiris, and the southern Sahyadri by Krishna et al. In 1996. This Western Ghats, this was basically got uplifted to the form of mountains during two periods. First was during the Miocene period, which is from about 23 to 5 million years from now. That is from 5 million years to 23 million from now is known as the Miocene period, and which was followed by Pliocene period, that is 2.58 million to 5.3 million years from now. So the sporadic uplift of Western Ghats occurred during Miocene period and the Pliocene period, which resulted or which influenced the landscape of the state of Kerala in a very big way. And we see laterite as a capping material, as a top material in most parts of Kerala, especially above the crystalline and sedimentary rocks. And in Kerala, the rainfall is very high, approximately about 3,500 millimeter. We call it as a bimodal pattern. Bimodal pattern means basically there are two rainy seasons with dry periods in between. That is what we mean as bimodal pattern. So here, the mean annual temperature is about 27 degrees centigrade, and the difference between summer and winter season temperatures is less than 6 degrees. So this type of regime is called as isohyperthermic temperature regime. Isohyperthermic temperature regime means annual soil temperatures are always higher than 22 degrees Celsius. That is the meaning of isohyperthermic temperature regime. Then this type of soils, they are also termed as ulti soils by various geologists, means highly weathered, leached, red or reddish yellow acidic soil. These are termed as ulti soils. And Krishnan et al. And others, they report that this cover more than 50% of the surface area of the state of Kerala, especially in the hilly terrains. Now, geologically, Kerala comes under the South Indian Shield. We talk about plates. And the four major geological formations in the state of Kerala are crystalline rocks of the Precambrian period. Precambrian period means the earliest parts of Earth's history is called as Precambrian period. Okay, these are terms coming under geology. And sedimentary rocks of the Tertiary. Tertiary is a period about 66 million years ago. That's known as Tertiary. And in these sedimentary soils, within that sedimentary rocks, we can see fossils. Then we have laterites capping this crystalline and sedimentary formations. The first two, the crystalline formations, and as well as the sedimentary formations, they are covered with laterite. The top portion, we have a capping of laterite. And fourth one are the recent and sub-recent sediments forming the low-lying areas like coastal area and river valleys. These are found, these details we can see in the publication by Geological Survey of India in 2005. And nearly 60% of the state is covered by either laterite or laterite-derived materials. And the process of laterization dominates the landform development in the state of Kerala. And even high altitudes, the remnants of laterites, hard cuts are found. And it has been developed on all types of rocks, including recent sediments and transported residual forms everywhere. Now, this transported laterite, which is also known as detrital laterite, means transported laterite, is basically found along the river valleys and along the slopes where this has been transported and deposited. And the lower part of this transported laterite deposits or this detrital laterite deposits are found to be merged with the residual laterite components. The transported laterite and the residual laterite are both found to be perfectly blended or merged. So the researchers are using a term welded. Both have been welded together. Now, in the top of this transported laterite or detrital laterite, the concentration of iron is controlled both by the soil forming processes and the contribution of upland laterites from where it gets washed away or transported and deposited. So the concentration of iron will then depend on both the properties of the detrital laterite and also the process of transportation and deposition. So I hope I gave you a small introduction to laterite soils and also about the laterite soils in the state of Kerala. Anyway, thank you. Thank you for watching.